Hello children, today my class is on locus and this is for the 10th standard and I want to help all the children who are going to answer ICSE or CBSE board examinations. So just to help you out, because what most of the children find difficulty in understanding the meaning of locus. You have done locus in the course of 7th standard, 8th standard as you're doing when you did equation of straight lines, solving simultaneous equations graphically, or elimination method or cross multiplication method, but you never realize what you were doing on graph, whatever path you were making, that's locus. Simple words, locus means a definite path. But when can a definite path be made? Right? When there are certain given laws. So locus is the path of a point. The point should be moving, not stationary. The locus is the path of a point, right? The path traced by a point under some given laws. If I say what is the locus of the tip of a pencil held by a small kid of 3 years, he will just scribble on the page. That's not locus. Okay, you see, I'll show you the kinds of loci. Loci is plural of locus. So you have locus. So this is for 10th, right? Even 11th, it will help you because you continue this locus in conics and furthermore in coordinate geometry. So, and the plural is loci, right? So locus is the path traced by a point, a moving point under some given laws. So when I draw like this has a fixed direction. It is locus. When I draw like this, it has direction. It's a locus. When I draw a U, it's a parabola. So it has a locus. When the earth is moving around the sun in an elliptical path, that has a particular path, a shape, that's a locus. That locus is called in geometry ellipse. If you have seen sound wave, you made in physics sound waves, or sine curves, or cos curves, that is also locus. So the locus can be expressed in 3 different forms and you've all done it, only it's a new name, right? It's just a new name. So you have locus can be described. It can be given, a description of the path can be given in statement form. So first, statement or description. So locus can be, I'll show you an example. It can be given in a description format. Second, a pictorial form, graphical form, or picture form. So the locus can be in pictorial form. Okay, this can be in the curve which you draw on graphs, or the graphs which you make, right? Third one, pictorial representation of locus. Third is an equation. So generally we are sticking in 10th standard with 2 variables, x and y. So equations, when you write x plus y equals 5 children, that's a locus of a straight line. That's called a linear equation because that equation, when drawn on a graph, it will give a straight line graph. So that's why it's called a linear equation. You have y equals x square. Okay, when you draw that, you learn it in 11th, parabola. When you have x square plus y square equals a number, say 7 or a 49, that's a circle. So each equation in 2 variables let us stick to 2 variables, represents a path, a locus, right? And you did not know this. Let us, for example, I give you one example. What is the locus of the tip of a pencil moving 2 centimeters from the edge of this board? Right? Now I have certain directions given to you, certain laws given to you. I did not say what is the locus of the tip of the pencil held by a 3-year-old child, because there's no law the child follows. He is just scribbling. He is just scribbling, and the scribbling has no design, no format, right? So, but now I'm asking you, so let us take the tip of a pencil is a point. We always ask locus of a point, and the point is moving. So you make, this is the edge of the board. So 2 centimeters from the edge of the board. So this is suppose say 2 centimeters. So you are drawing, the point is moving, my pen is moving. The tip of the pen is moving. So it is moving at a distance of 2 centimeters. The pen is moving at a distance of 2 centimeters from the edge of the page. Right? I'm drawing big. So therefore when you join us, please end in arrows. And this is the edge of the page or edge of the board. So you are getting 2 centimeters. So this is the difference. Let me draw a straight line. So this is 2 centimeters. This is the tip of the page, a pen moving or pencil moving from 2 centimeters from the edge of the page. So what was my law given to you? That there's an edge of a page and the movement of the point should be 2 centimeters from there. So everybody will draw correctly. If it's from the edge of your book, you have your notebook, you draw edge of the notebook. So now you will explain description of what path you got. If you simply say the locus is a straight line, my question is, what is the locus of the tip of the pencil or an ant moving, okay, anything, any moving particle? That object is just reduced to a point, right? So what is the locus of the point moving 2 centimeters from the edge of this board or edge of the page, okay, or from a wall? So you make at least 3-4 positions of that point, and it is going on moving. Okay, so this locus has no end point or starting point. So here is 2 centimeters. So your description will be, it is a straight line parallel to the edge of the board, parallel to the edge of the book, right? Moving at a distance of 2 centimeters. Or it is a straight line at a distance of 2 centimeters from the edge of the book, edge of the board, whatever it is. If you just say it's a straight line, it is wrong, children. Because I can draw infinite straight lines on this board, on your book. Okay? If you say a straight line parallel to the edge of the book, that is also wrong. Why? Because I can draw infinite lines parallel to the edge of the book. I have to only follow that path which has been described. So I have to say it's a straight line, number 1, parallel to the edge of the book, number 2, and number 3, it is at a distance of 2 centimeters from it. So that is the description of this particular locus. Now I said this is the pictorial form. What I made is pictorial form. So the question which I asked you, this is the edge of the book and this is the locus. You draw a dotted line and show 2 centimeters. So this is the picture of my locus. My explanation, I told you, it's a straight line parallel to the edge of the book, which is represented by this line at a distance of 2 centimeters. You have to say the distance, and you also have to say the distance as well as, children, you have to also say parallel to the edge of the book. Parallel to what? At what distance? Now this very same question, if I ask you, like, take on a graph paper, if I say draw what is the locus of a point moving at a distance of 2 centimeters from the y-axis. So I have a graph. You don't need a graph paper. Just you have to draw the locus. So this is y-axis, this is x-axis, this is y-axis, this is origin. So this is 1, 2, 3. Okay. And then it's very particular. What is the locus of a point moving 2 centimeters from the y-axis? This is my y-axis. So say like this is 2 centimeters. Again you show a point. That means the point is moving downwards. Arrow. So you can see a nature of the point. So same answer. It's a straight line parallel to the y-axis at a distance of 2 units from it. But children, suppose this was like 4 marks, you would have got 2 marks. Because they said draw the locus, maybe on a graph paper of a point which is at a distance of 2 units from y-axis. Some child does this and some child does this. Okay, 2 units he does on the left side. Maybe he's a left-handed. Not necessary. One has drawn this one has drawn this one, and both are correct. So who is correct? The one who has drawn both. So it is, unless it is said it's on the right of the y-axis, then this is the line. To the left of the y-axis, this is the line. But I did not mention about left and right. Therefore, it is a straight line parallel to the y-axis at a distance of 2 units from it. So it can be this as well as this. Is it clear? So now that is description. But here I will say write the equation. So that was description, statement. This was drawing. Now if I say explain this drawing in equation form, okay, write the locus, that is explain the locus. Explain the locus, a straight line parallel to y-axis at distance of 2 units to the right and also 2 units to the left, right? Equation, a straight line, I'll do the equations of in coordinate geometry later on, but you know a straight line parallel to y-axis will be x equals 2. You know that? So this answer and this answer, both. This is x equals minus 2 because this point is minus 2, 0 and this is 2, 0. So there you can write x is plus minus 2. So 2 loci. This is one locus and this is one locus. More than one path, you say loci. L-O-C-I. Okay. So that means x is 2 and x is minus 2. So you have 3 formats of equations. Sometimes you see the teacher says, like there are many kinds, so this will take time, children. So I will give you 4 to 5 videos on locus, please, and it may be continuation from today to another. So it's not like as I said Wednesday and Sunday. Now I may give you a lot of, because locus I want to do slowly, so it helps people who are answering ICSC children. Okay, this is for all my ICSC children, right? So I will continue, please, for 4 or 5 of these videos because it cannot be continued and I don't want to bore you up more than 10, 15 to 20 minutes, right? So therefore, this is one. Suppose I say, see how it is asked, right? So what is the locus of the center of a car wheel? That's all. What is the locus of the center of a car wheel? Now car wheel is moving. Where does it move? In the sky? No. Right? Where does it move? On the road. So it's understood to make up the road. And the car wheel, the same car, locus of the center of the car wheel. That means as the car wheel is moving, locate what would be the position of its center. So take minimum 3 to 4 positions and join those positions, you will get the locus. So, and remember, car wheel does not increase or decrease in size. It is the same car. So you have make wheel, same size, 3 or more circles, which represents the car wheel, and then this is the center. So join it. So children, the one which is shown in arrows, that is the locus, and this is the street. So now this is the drawing. The drawing of, always, even if in the question you get what is the locus of the center of a car wheel, you always draw. Because drawing and pictures goes very fast to the brain. Somebody hears a story of a picture or somebody sees a picture. The one who sees the picture, the story remains for longer period in his mind. Okay, so narration and action different. If I act, you'll understand better, right? So here, draw it, even if it's not asked. It's very clear to the mind. Locus of a point is always asked, not locus of the entire object. A particular point of a figure will be asked. Center of a car wheel. So draw the car wheel, and the car wheel is moving. Locus is always to do with a point moving or a set of points obeying the same law. Okay, so here this is center moving, car is moving, make minimum 3. And you cannot make like this and like this. Then it will not be. Because you're trying to tell me that the car wheel is becoming big and small and big and small. That's impossible. So same car wheel. So what is the locus? It's a straight line. Now describe. Now my question is, what is the locus of the center of a car wheel? So you have to give the description. It is a parallel line. The dotted line I'm talking about, children. It's a line parallel to the road. That's not correct. Incomplete. If I say it's a straight line, incomplete. Because straight line can be in any direction. It's a parallel line, incomplete. I can draw many parallel lines to the road. So it's a straight line parallel to the street at a distance equal to the radius of the wheel. Whatever is the radius of the wheel, whether it's a car wheel or cycle wheel, whatever is the wheel, or a truck wheel, whatever is the radius. So my complete answer, children, is straight line wrong, parallel line wrong. So what is the correct description? It's a straight line parallel to the road at a distance equal to the radius of the wheel. Whatever is the radius of the wheel, that completes. So everybody will follow the path. If somebody asks you the address and you tell the man, go right, go left, go straight, go and take a roundabout turn and then go right again, you are not giving the person the right locus, the direction. He will not find the correct house which he is looking for, right? So this is now, suppose the same question how they ask, they ask, what is in geometry? Now the same question, the questions can be twisted, children. This is car wheel. Now I will ask you, what is the locus of a center of a circle touching a given line xy? Same thing. It is the same thing. The xy is the road. What is the locus of the center of a circle touching a given line xy? So I draw a line xy. And what is the locus of the center of a circle of radius 2.5 centimeters? Touching a line xy. In geometry, again you are making a circle and another locus. The circle is moving, then only the center will make a path. A stationary circle does not make any path. It's a dead point. You're standing on the street for hours and hours and hours. You have not made any kind of curve. You're not moved along a curve or a straight line. So this, and the same circle radius 2. Same question. What is the locus of the center of a circle touching a line xy? So this line has a name. That's called tangent. Because if a circle touches a line at one point, that only touching a line, that line becomes the tangent to the circle. So xy becomes the tangent. So again you join the different positions. Again you say it's a straight line. Wrong. It's a parallel line. Incomplete. So what is complete? A straight line parallel to xy at a distance of 2.5 centimeters. Because here now I gave you the radius of the circle. I just gave you the radius of the circle. Okay, so that is touching a line. So here it is geometry. So if I say, what is the equation? Give the equation or give the locus of a point, okay, or center of a circle or a point moving at a distance of 2.5 centimeters from touching the x-axis. Touching the x-axis, what is the locus of the center of a circle? So this is x-axis and this is 2.5. So this is the same description, you'll give the same, drawing you'll do the same, right? But if I ask you the equation, that will be y equals 2.5 or y equals 5 by 2 or 2y equals 5. All this is the locus of this if the line is the x-axis. So when I just said any line, that is tangent. If I said x-axis, then I can give a relation because coordinate geometry deals with the relation between x and y. So that's why if I say x-axis, it's a straight line parallel to the x-axis, a distance of 2.5 from it. That is y equals 2.5 or y equals 5 by 2. Okay. So I continue in my next video, video number 2. Children? Okay. Thank you.